yeah, you're recording. Turn this off. So keep the dice in front of you. I'm gonna need you to use them soon. Do we have any more dice floating around? Is the bin around somewhere? Oh, there we go. Perfect. If you don't mind just sharing around, Michael, that's awesome. And it helps if you have two different colors, if you can. If you can. Who else needs them? Go ahead. Just like in church, best what you best. There you go. Spare me number 2. Let's roll 2. Nice. Yeah. What I want to try to do with this one is, I want to try to build the distribution before doing the experiment. And there's a reason for that. So first of all, if you're throwing a pair of dice, what are you interested in? Craps.
Pips.
Oh, pips! They say craps. Well, craps, I mean, it's craps dice. Craps dice. You'd be interested in what you get on the faces, right? The sum total of the pips. Exactly. So the random variable this time, instead of just being the pips on one die, it's the sum of the pips on both. And, you know, there are other games that don't just use the sum. Some games use the difference. You know, you might have one person roll one die, one person roll another, and whoever gets the highest number goes first. That's like when me and Max play Star Wars Sorry. That game was Sorry, Star Wars with the R2-D2 in it. Every involves rolling 2 dice, and he always beats me. Which I can't explain, but whatever. It's chance. He's cheating. He's 6 years old and he's cheating already. That's his mother. Jen. So, what are the values of that random variable? 2 through 12, yes? Because you get snake eyes. You get snake eyes, you can get a 3, you can get a 4, and the highest you can get is double 6s. Can't get any higher than that. So now we know all the values of the random variable. Good. Let's put some probabilities on these. What do you think? Chance of a 2, chance of a 3, chance of a 12, chance of anything really. What do you think? Any starter ideas? Amy's going to say there's 11 possibilities.
Yeah, so 1 out of 11.
So 1 out of 11, yeah?
There's different ways to get like 6. There's 2, 4, 1, 5.
Okay, so there are 11 random variables. True. 2 through 12 is 11 there. One thing we can say is make them all 1/11. But that forces them to be uniform like this. What we have to kind of think about though is, can we make that assumption when we have 2 dice? And there's nothing to say that we should or shouldn't until we start thinking about it. Kate, what are you going to say? Go ahead.
Oh, I was just going to say, well, with 2, there's only one way to get it.
Okay, everybody grab your dice right now. Make snake eyes on your dice.
And you have...
Hold that thought. Hold that thought.
Okay.
Make snake eyes on your dice. Get them in front of you. Okay, make it a different way. Megan glares at me. Because you can't make it a different way. There's one way to have it happen. One way to have it happen. Thank you, my friend. There is one way. Oops, I was kidding. There's one way to do it. And now use your project you just turned in to tell me how many possible ways you can throw 2 dice.
1 pair.
3 is related. But you can throw the... 1 in 3,000. There's a 3. How many ways can you throw a pair of dice?
36.
So, 1 die can be thrown 6 ways. The second die can also be thrown 6 ways.
And then you multiply.
You multiply them because you're doing it in sequence. It's an AND problem, not an OR problem like back in the day. That was the big... Did you guys catch the big difference between the Project 1 and Project 2? I mean, yeah, it seemed a little bit more obnoxious. Project 1, besides... Project 1 was all about adding. Project 2 was all about multiplication. And that's the difference. Are you ORing or are you ANDing? This is an AND. Roll a die and then roll another one. There's 36 possible ways for that to happen.
Another way, the way I was looking at it, which is the same thing, but
Go ahead.
I was seeing as there's a 1/5 chance of you rolling the 1 on this dice, and there's a 1/5 chance of you rolling a 1 on this dice.
I love that. Multiply them together. Multiplication rule independent events. I never taught you that. I'm not going to mention it ever again, but that's 100% correct.
I was just saying if you have a hard time
I love that.
conceptualizing.
Sister, I love it. It's beautiful. It's beautiful. It gets a little tricky when you move down the distribution. Everybody, make a 3 on your dice. A sum of 3, I'm sorry, a sum of 3. Sorry, thank you, I'm going with the definition of our random variable. Sum of 3. Good. Okay? Do it again, a different way.
Are we assuming that it doesn't matter which dice you roll a number on?
Answer that question Kate just did. I just said to make it 3, and everybody made a sum of 3, right?
Because you-
Then I said make it a different way, and Kate asked a very good question. Does it matter? Jen, may I borrow? Actually, I'm not going to borrow yours. They're both red. Patrick, may I borrow yours? Not because I don't like you, Jen, but because they're both red.
Sure.
All right, watch this. There's 3, right?
Yeah.
I got a red 1 and a white 2.
That's 6 times 6.
Can I make 3 a different way? I can take white 1 and red 2. That is a different. That's a different sum. I mean, it's the same sum numerically, 3. But because I had to turn the dice to a different face, those are different faces, yeah? Different faces. Still a sum of 3. Good. So we've got at least 2 ways. Make it a third way. You can't. So there are 2 ways to make 3 out of 36. Excellent, friends. All on our way. All on our way. Make 4, please. Make a sum of 4.
Sean, go on your trick test.
Oh, crap. Monty is. Money! What color you got right there, Andrew?
Red.
Red. Let's give you a white one. Here we go. There we go.
Go.
So you got 4? Do it again. Right. Now you're up to 2, right? You've done it 2 ways.
Oh.
Do it again. Do it again. Jenny's got a vote. We can't, can we? You can because what are the ways to make 4?
2 and 2 and 1 and 3.
And 3 and 1.
Yes.
Now, does it bother anybody? See what Jenny just said? There's 3 ways to make a 4. There's double 2s, 1 and 3, 3 and 1. Why aren't we counting the double 2s twice?
You're not turning the face.
It's just like Snake Eyes, right? We're not turning anything. Exactly, Heather. We're not turning. This was Snake Eyes. When you put 1 and 1 down, you're not turning the dice to get 1 and 1 again. Same with 2 and 2. Any doubles only gets counted 1 time. So 2 and 2, 3 and 3, 4 and 4. There's no 2 of them. But there are 2 in any die where the numbers are different because of the colors. Does that make sense? It's a little tricky to kind of wrap your head around that at first, but you'll get the hang of it. So that's 3 and 36. Okay? Make 5. Please, of course. Please. As a matter of fact, finish the distribution out. Finish it out. Have at it. Have at it. You guys can do this now. I think you see the